everyone, we're here today looking at notes 2-4, transform absolute value functions, and this is actually part 1 of part 2. Part 2 we'll get to here in a couple of days. So actually, before we get to all this fun, we are going to start with our parent function or pink notes. So pause me real quick if you need to and go grab those. Okay, now I'm assuming that everybody has their parent function or pink notes in front of them and that they have their name in the upper right hand corner, hint hint. All right, so today we're only going to be filling in 2 of these parent functions, the linear parent function, which we know a lot about, and the absolute value parent function, which we're about to find out a lot about. So the linear parent function we'll start with is the function y equals x, and if we plot that graph using slope-intercept form, of course the intercept, the y-intercept, it's like plus 0 is implied here. So the y-intercept is 0, 0. All right, the slope is positive 1, so you would go up 1, right 1, or down 1, left 1 forever. Okay, and I've chosen these specific 3 points. Remember when you graph a linear equation or function in my class, any linear graph, that you need minimum of 3 points. So we've chosen these 3 points for your parent function notes, okay? These 3 here. So our domain and range, we will write domain and range in set notation all the way throughout your whole pink notes, just so you know. Our domain and range for the linear parent function are both all real numbers. The graph spans left and right forever, down and up forever. Like we said just a moment ago, the x and y intercepts are 0, 0, so the graph crosses through both the x and the y axis at the origin at 0, 0. And I'm sure you remember this fancy word here, asymptote, from notes 1-1 part 2. This graph has no asymptotes. Okay, we'll get to some graphs with asymptotes later in the year. Okay, so now let's talk about our new parent function, absolute value. So the absolute value parent function is the function y equals absolute value of x. All right, and before we get to the graph and all the attributes, let's talk about what absolute value means. So I'm not going to go into too much detail just because that's coming up in a later video, actually. So what I will say is that absolute value represents distance, okay? And distance can never be negative. So that's why when you take the absolute value of a number, it takes that number, and if it's negative, it makes it positive, and if it's positive, it just stays positive. So the absolute value of -6 is 6, the absolute value of 6 is 6, and so on and so forth. So some examples for you. So you don't need to write this down. I just wanted to quickly give you a brief overview. So how did I graph this graph? That's a great question. I'm so glad you asked. So I picked some inputs, and specifically I picked negative inputs, 0, and some positive inputs because I wanted to see both the left, the middle, and the right of the graph. Okay, and I plugged those inputs in for x, of course, right? So if I plug in -2 for x, the absolute value of -2 is positive 2. Positive 2 is my output. If I plug in -1 for x, the absolute value of -1 was positive 1. Okay, the absolute value of 0 was 0, the absolute value of 1 is 1, and the absolute value of 2 is 2. And then I graphed this graph, and I used a straight edge, of course, and I used a straight edge on that one, I promise. Okay, I used a straight edge, of course, and I drew arrows on both ends. I drew arrows on both ends on this graph because I knew I could have kept going 3, 3, 4, 4, and then in the backwards direction as well, -3, 3, -4, 4, etc., etc. So that's why I put the arrows on both ends. So that leads me to my domain and my range. So my domain, of course, with the arrows on both ends, since this graph spans forever left, forever right, is also all real numbers, x such that x is an element of all real numbers. Our range makes sense based on our graph, y such that y is greater than or equal to 0 because 0 is my low point and all my y values increase from there. And it makes sense based on what I was saying earlier, that all your outputs will always be positive. So y, or your outputs, will always be positive or 0. Okay, our x and y intercept is 0, 0 for this graph as well. All right, so 0, 0 is our x and y intercept, and asymptotes on this graph also none. I promise we'll get to some asymptotes later. Okay, so these are parent functions, and they're called parent functions because they're the most basic form of this family group of functions. So what we're going to do today is we're going to take this parent function and we're going to transform it. We're going to make it less basic, more fun. Okay, so we've got our parent function and we're going to transform it. So I've actually taken this table. You're going to have to memorize this table. You're going to have to know these points. Okay, I've taken this table and I've transferred it onto our notes for today, so that way we don't have to keep flipping back. So there's our parent function points, just so you know. Alrighty, so let's get started with all this. You probably want to stop and pause, so that way you're not rushing to copy instead of listening to me, because if you don't listen, then you probably will be confused and you'll probably get frustrated. Okay, so it's going to be a lot today, I'm not going to lie to you, but I'm going to try and go as slow and as easy on you as I can. So let's talk. So we're taking the absolute value parent function and we are implementing these A, C, and D values. So what does A do? Well, A changes the points on the table. So A changes the points on the table. You will multiply your Y values by A, while C and D change the origin. Okay, so they will shift the graph left, right, up, and down. We're going to talk about that here in a minute. While the A is just going to change the points. Okay, and again, I'm going to go through this here in a minute. Okay, quickly I'm going to go through this. So take the A value, whatever that value is, take the absolute value of it. If it's greater than 1, it's a vertical stretch. Okay, so A deals with either a vertical stretch, a vertical compress, or shrink. Those words can be interchanged. Or a reflection over the x-axis. So a reflection over the x-axis is a vertical reflect. So all this stuff is vertical. I know that says x and that's confusing, but a reflection over the x-axis is a vertical reflect. So you're going to have to take a look at that value, examine the value, see if it's going to be a vertical stretch or a vertical shrink or a reflect over x, okay? And then you're going to look at what is the C value, and I don't want to get too much into this and bog you down and confuse you, but you're going to take a look at the C value. Now notice that's a minus sign there, well that's a plus sign there. So really I'm going to kind of ignore this for now and just tell you that C will shift the graph either right or left. And it's going to go based off of opposite of your intuition, meaning opposite of what you think. And again, when we get down here, I'll explain more. But the C value is going to shift right or left. The D value is going to shift you up or down. Okay, the D value is going to shift you up or down, and that does go with intuition, meaning how you think. Okay, so we're going to talk about that here in a minute as well. So let's get started with 1 through 6. State the transformations with regards to the parent function. Graph each function. Okay, so on number 1 here, what is the transformation with regards to the parent function? Well, look at the difference between the parent function and this guy. The difference is this little -3 here. So does that -3 correlate with A, C, or D? You're right if you're screaming at home, D. That's a D value. Okay, and when D is less than 0, we go down. That makes sense. That's with our intuition. That's how we would think. If I saw this -3, I'm thinking if my choices are up or down, I'm thinking minus is going to move me down. So that's with intuition, that's how I think. So the -3 shifts the graph down 3. And what that means is I'm going to literally pick up my origin and I'm going to move it down 1, 2, 3. So here's my new origin. It's a plus sign, okay? That's my new origin. From my new origin, I'm going to simply graph my original parent function points. So from here, I'm going to go left 2, up 2. From my new origin, I'm going to go left 1, up 1. From my new origin, I'm going to plot a point on my origin. And then from my new origin, right 1, up 1. And then lastly, right 2, up 2. Remember, you've got to include all 5 points. And then, of course, you're going to use your straight edge, arrows on both ends. And that's literally it. That's not too bad yet, right? Okay, so now let's examine number 2. So how is this different from the parent function? Okay, this is different from the parent function because of this -2 here. And so that correlates with your C value, yes? And again, I'm not really going to look at that yet. We'll talk about that later if you want to. It kind of confuses students generally. I like to put it so we can refer back to it, but for now, we're just going to kind of go off of this. So this acts opposite of our intuition. So me personally, if I know my choices are either right or left, I'm thinking minus means left, but it's opposite of what you think. So this actually moves right 2. Okay, so this guy moves opposite of what you think. It's the C value, so it moves right 2. Okay, so I'm literally, like I did before, going to pick up the origin and go right 2. Okay, there's my new origin, and from there, I'm going to plot my original x's and y's. So left 2, up 2. From my new origin, left 1, up 1. 0, 0, and again, I'm always going back to my new origin, and then right 1, up 1, and then right 2, up 2. Of course, I'm going to gather my straight edge here. And then I'm going to finish it off. Okay, number 3. So number 3, how is that different from the parent function? It has this 2 out in front. So that correlates with my A value. So remember that A value changes the points on the table. Remember that before we had D and we had C, and those changed the origin. So the D and the C changed the origin like we did. We moved the origin. But A changes the points. Okay, so my origin doesn't change here, just my points. So I'm going to take my original table. Oops, and I have to write my transformation down, don't I? So I need some room. I'm sorry. Okay, I'm going to take my table and write down my original table, and then I'm going to do exactly what this says here, and it says multiply y by a. Okay, so a is 2, so I'm going to take 2 times y. Okay, multiply my y values by a, so 2 times y. So that means this is going to become 4, 2, 0, 2, 4. Remember, I'm multiplying my y values by 2. Then I'm going to cross out my original y values. I don't want to look at them anymore. I want to look at my new ones. Okay, so let's talk about the words here, the transformations. What do I put here? We'll examine the a value. Look at that a value. And if you take the absolute value, so it's definitely not, a is not less than 0. Okay, so that's not the case. So it's not a reflection. So then I'm going to look at the absolute value of 2, which is 2, and that is greater than 1, so that's a vertical stretch. Okay, that's a vertical stretch. I'm always worried that I'm going to spell this wrong, and stretch always looks like it's spelled wrong to me. I don't know why, but it just does. So this is a vertical stretch by 2. Okay, so then my origin doesn't move. It's just my points that change. So -2, 4 now, -1, 2 now, 0, 0, 1, 2, and 2, 4. So hopefully, just like you've been kind of checking as we've been going, hopefully you have. This looks just like what our word said. So before, hopefully you were like, oh yeah, down 3, that's what that looks like. Oh yeah, right 2, that definitely is what that did. And here, oh yeah, vertical stretch by 2. Yeah, we literally took the graph and we stretched it out vertically. That's why it's skinnier. Okay, so we took the parent function and we stretched it. Okay, number 4. So number 4, again, we have a change on the a value. So how is this different from the parent? It's that -1 out in front. So the a value here is -1. Okay, so the a is less than 0. So that's called a reflect over x-axis. Okay, and we're still going to follow the directions. So we wrote down what it is. We wrote down our transformation. We're still going to follow the directions for a. What happens when we have a change with our a value? We're going to multiply the y's by a. So I'm going to take my original points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Aren't you glad we wrote this table here so we didn't have to keep flipping back to the pink notes? All right, so now we're going to take our y's and we're going to multiply. Here, remember we multiplied y by 2. All right, here we're going to multiply y by -1, or just going to write -y because that implies the -1. So this will become -2, -1, 0, -1, -2, and then cross out the originals because you just want to plot the news. Now remember, my origin didn't change, so I'm just plotting from the true origin. So -2, -2, -1, -1, 0, 0, 1, -1, and 2, -2. Okay, so doesn't that look like a reflection over x? You're screaming at me at home, right? You're saying, yeah, it does. Okay, so we took the graph and we reflected it over the x-axis. All right, let's move along. Number 5. So number 5, we're starting to combine some things. So we've got an a value here, a c value here, and a d value here. So when we have lots of changes, we take care of the origin first. So we take care of c and d first. So let's move the origin first. So the +3, remember, inside the c value moves either left or right, and it's opposite of intuition. So I know it's weird, but that +3 is actually going to shift the graph left 3. Okay, outside here, that's our D value that moves the graph up and down, and that's with intuition. So either up or down, then I'm going to say down because that makes sense. Down 5 because that goes with intuition. So left 3, down 5. So we're going to pick up the origin and go left 1, 2, 3, down 1, 2, 3, 4, 5. There's my new origin. Then let's talk about the A value. What's this A value mean? Well, it's not negative, so it's not a reflect, okay? Then we look at the absolute value of this number, so that's a half, okay? And a half lies between 0 and 1, right? So that's a vertical, compress, or shrink. I usually say shrink, so I'm going to say vertical shrink by a half. And that means if I stretch, shrink, or reflect, that means I'm going to have to alter my table. Because remember, that's what the A value does. It alters the table. Okay, multiply the Y values by A. So now we're going to take the Y values and multiply them by a half. So first I'm going to record my original points, okay, from the pink notes. So there's my original points from the pink notes. Now multiply the Y values by a half. So 1, a half, 0, a half, and 1. That was multiplying the Y values. Cross those out, and now all these get plotted from the new origin. So left 2 up 1, left 1 up a half, 0, 0, 1 a half, and 2, 1. Okay, so doesn't that graph look like it did all those things that we stated? Did it move left 3? Yes. Did it move down 5? Yes. Did it vertically compress or shrink? Yes, it sure did. Okay, so for number 6, we've got a whole bunch of stuff going on. Okay, so we've got an A value, a C value, and a D value. Like I said, we're going to move the origin first. So we're going to deal with the C and D first. So remember, inside here is either left or right, and it's opposite of intuition. So that's not going to move right 1. It's going to actually move left 1. So we're going to move left 1. Outside here, that D value moves up or down, and it's as you think. So I would say up 4. It's as I think, it's up 4. Okay, let's talk about, well, let's go ahead and move the origin. So left 1, up 1, 2, 3, 4. Let's go ahead and do that. Let's talk about this now. Oh, sorry, this right here. So that -2. Okay, so that is going to be 2 changes. So the negative, remember, if A is less than 0, we reflect over X. So we're going to say reflect over the X-axis. Okay, and then, so the negative makes it reflect, but the value here actually makes it do something else. So if you take the absolute value of -2, and it's 2, so that 2 actually makes the graph vertically stretch. So the negative makes it reflect, the 2 makes it vertical stretch by 2. So it's only the A value that's kind of can be 2 separate things. So like I said, if there's a negative, that makes it reflect, and then you have to ignore the negative, essentially take the absolute value of this number, ignore the negative, look at the number, and then notice, is that number going to be a vertical compress or is it going to be a vertical stretch? So that's how that works. Now I'm going to take my A value and I'm going to multiply my A value by Y. Or my Y's by A. So -2 times Y. So I'm going to record my original points. And then I'm multiplying my Y values by -2. So this would be -4, -2, 0, -2, -4, right? Multiply my Y's by -2. So from my new origin, left 2, down 4. Okay, left 1, down 2, 0, 0, 1, -2, and 2, -4. All right, we're getting close, but there are still some things. I forgot to fill something into the pink notes, so I'm going to need you to get those real quick. Okay, so now that we're done with the graphing, I want to talk to you real quick about something. So on the pink notes, this point here, the tip point, is called your vertex of the graph. So just so you know, when I start talking about absolute value graphs more and more and more, I will refer to this point very often because it's a special point. It's called the vertex. And then this line right here that I'm drawing, this dashed line that I'm not using a straight edge for, oh my gosh, that's terrible. I'm really upset about that. Okay, this line here is called the AOS, or axis of symmetry. All right, so that's the axis of symmetry. It cuts the graph in half. So I forgot to add that earlier. So there you go. That's the vertex, that tip point there, and that's the axis of symmetry, the graph that cut the, the line that cuts the graph in half. Okay, so what I want to add to you here real quick is on this part. So because we just talked about this and what I was saying earlier, so if A is less than 0, it's a reflect over the x-axis along, in parentheses, along with your vertical stretch or shrink if applicable, however you want to say it. Okay, so sometimes it'll just be a reflect, like in this case it was just a reflect because it was just a -1, or sometimes it'll be a reflect with a stretch or a shrink, so make sure you get that in there. So I'll hold it there for you for a minute so you can get that. Okay, so that's going to bring us to the last part, and we're going to need to know all that stuff. So write an absolute value function matching the description. So the parent function, f of x equals absolute value of x, is translated 12 units up and 6 units left. So remember, up and down is the d, that's your d, and left and right is your c, okay? So we're going to write our bones of this and see where we need to put the fun stuff. So d, remember, up and down goes on the outside here. Okay, and that goes with intuition. So if it's saying up, 12 up, then that's going to be your plus 12. This 6 units left, that's definitely going to go inside right here, but is it going to be a plus or a minus? So you would think it would be minus, but remember, inside is opposite of intuition, so it's actually going to be plus for left. Remember that. Okay, and I really didn't need this space here for an A because we didn't have a vertical stretch, shrink, or reflect, but it's okay. All right, maybe we will on the next one. So still make sure and put that room. Okay, so for the next one, the parent function is stretched vertically by a factor of 8, translated 7 units down, 3 units right, and reflected over the x-axis. Wow, that's a lot. Okay, let's start with the, we can start with the stretched vertically by a factor of 8. So stretched vertically, that means that's our A value. Okay, that's our A value, and the 8 goes right here where A would go. Okay, translated 7 units down. Down is our D value. Okay, down is going to be -7 on the outside. 3 units to the right, remember right or left goes in here. And you would think it would be plus, but it's actually opposite of intuition here, so it's minus. And then last but not least, remember that reflection over x comes from that negative on the outside, right here, right directly in front, I should say. All right, that's it for today. Thanks for bearing with me on such a long video. I hope it's starting to all kind of make sense for you. I hope you have a great day.